Genesis quantum exists to turn fragile quantum experiments into systems that actually work in the real world. For decades, quantum science lived in laboratories. Today, the problem we face, security, sensing, health, have outgrown classical technology. The gap is no longer scientific, it is engineering, and that is the gap we are here to close. Modern digital infrastructure assumes that computation is hard and measurement is reliable. Both assumptions are breaking. As computing power grows, mathematical security weakens, and classical sensing reaches its limit. Software sits on top of these assumptions. When the foundation breaks, software alone cannot fix it.
The solution lies at the smallest conceivable scale, the quantum scale. Genesis Quantum is a deep tech company with a singular mission: to translate frontier quantum and photonic science into deployable hardware. We are bridging the gap between the theoretical and the tangible. We believe that the true precision, unprecedented sensitivity, and unbreakable trust can only be achieved by engineering at the physical layer. We don't just manage data, we master the photons that carry it. The core capability of Genesis Quantum, the foundation of everything we do, is single photon instrumentation. We engineer systems that operate at the single photon level. Using advanced technology like single photon avalanche diodes, we can detect time and count individual particles of light with astonishing precision. This isn't just about better sensors. It is about unlocking a new tier of reality by engineering the fundamental physical layer. In simple words, we play with light. By precisely designing where these photons, or quantum dots, attach to, we can make light interact with different substances and transform into measurable data.
Miniaturization is not about size, it's about control. Large systems work in labs because engineers constantly manage them. In the field, systems must manage themselves. Photonic integrated circuits remove degrees of freedom that cause instability. They reduce variability and enable repeatable, scalable deployment.
With quantum key distribution, we go one step further. Instead of just detecting the light, we use photons themselves to carry and protect information. We encode secret encryption keys into single photons and send them securely across networks. So one of our devices is about catching the photon, and the other is about sending the photon as a trusted messenger. And our product strategy is focused on leveraging our core technology across different verticals.
Quantum key distribution relies on physical laws, not mathematical assumptions. Any intersection leaves a detectable trace.
The same quantum physics used in areas like quantum security is applied to medical diagnostics. The hardest problem isn't computation, it's signal. And with conventional systems, they're often lost in the background noise before they can even be detected. That's why sensitivity matters more than the raw computing power in early diagnostics. This is how quantum physics translates directly into saving lives.
Quantum physics is now an industrial necessity because we have reached the limits of classical scaling. Quantum technology is no longer an upgrade. It is a new operating regime required for modern infrastructure. Frontier science proves something can work once. Deployable technology proves it works every time. Our hardware represents the bridge between the two. In 10 years, you won't notice quantum in everyday life. Security will be default, diagnostics will be earlier, system will fail safely. What remains is trust.